So, hello everyone, and welcome back to this brand new live stream. Today we're going to continue the implementation of the HTTP server from scratch, more or less, because today we're probably using OpenSSL as we left off last time. So, so last time we actually tried to set up OpenSSL. I never really did that before, so this was the first time. And I was kind of struggling to set up all of the things while it was more or less just copying. I tried to fiddle around with the build system to make it such that we can selectively compile with TLS and without TLS. And yeah. So today, again, we're looking into this, how to get TLS working. Exactly. So where did we left off? Where did we leave it off last time? Maybe first change the title actually to day 9. And where did we left off? So when we make clean and make HTTP server with debug mode enabled and TLS, and we execute this, our program just immediately returns and we don't get any error message. So this is already quite bad. Yeah. So in this case, we should add some way of logging. We just call it a day with just saying, okay, -1 everywhere. But I think we should do some preliminary logging here. So, I already try to do this here. So I just use fprintf, print a standard error. Cannot acquire, and I just do that over and over again for each of the return -1s here. Cannot acquire SSL context. Cannot load certificates. Cannot load private key. Yeah, and I think this should be it. And how do I forward standard error to standard out? I think it was like this. So it doesn't do anything. So let's go into GDB. And run this. So break at serve. Break at serve. Run this. Next. So we print the context. So we have a context, incomplete type. Oh, return -1. So we were unable to establish a context, but I mean, to me, this seems like Okay, so we cannot acquire the context. So I think this is the problem here, because I think we have to initialize it to 0, to null, and then say context is equal to this. And the same thing holds true for the SSL object. We say, okay, so we did that because it doesn't modify it unless it's null, I guess. Break serve run p context next p context. Okay, so it initializes it. So we don't have to do it, I guess. If not context. Is this an invalid? A not pointer C. Oh. Not pointer in C. Use the pointer. So I don't really understand why that is the case here, why it returns. This. This is weird. So this pointer is set, but it somehow isn't. And the fprintf is also ignored. Maybe because of this here. Two and one. Still GDB, HTTP. Oh my god. When adding this, we forgot to let's read the description for this. Does the same. So I think we should be fine doing just this here. We forgot to make the scope broader. This is kind of a disadvantage of using no braces. That is, if you add some lines to your file, to the branch, then it doesn't really work anymore. Yeah. Okay. So break, serve, run. But still, context is set. False. This is false. What? What is this? What is going on? It runs. What is going on? Okay, it was probably just that this wasn't actually working. So we have it running. So localhost unable to connect. Okay, so we have a SAC fault, so that is bad. So this is already quite bad. GDB print function of SAC fault. Header requests. Okay, so this tries to create a new context. Do we have to create a new one every time? Do you have to create a new SSL? Create SSL new. Which is needed to hold the data for TLS. Pointed to an SSL structure. So this can return null. Check the error stack. I don't even know what the error stack is. So if not SSL, it's probably where it all broke loose. So this is null. Do you create a new SSL object for each connection? No. OpenSSL. So how did they do it in the SSL echo? How did they do it? SSL new. So they accept and then create a new one. So we could say if SSL so if we have no SSL, we go to close client socket. And we also fprintf standard error cannot acquire SSL object. Cannot set fd for SSL object. So return your value, the operation failed. Oh, so if not, okay, so this seems correct. I think this can return null. Null, yes. And this, the TLS handshake was not successful but was shut down controlled and by the specifications. Call SS error successfully completed. So okay, so this is correct. Cannot establish SSL connection. Oh no, same thing here. Almost did that again. So to do is check for the individual return values. Oh. Okay. So HTTP server, no, GDB and break handle requests. Handle requests. No. Run. Next. Oh no. Okay, now it tries to accept. So let's try to do something like local host index.html. Cannot require SSL object. Are they doing it at the same time? So, first of all, maybe we should run it on one thread. Okay, so now we're trying to accept. Okay. Ooh, okay. So now we have a problem here. I think we are in a race condition. No. Oh no. Did we forget to set? So, did we forget to set it? Where we spawn the threads? Oh yeah, we did. Worker args, no. Handle request. So it gets a context. Yeah, so we forgot to set that. That obviously will fail. So make it again. GB. And where do we accept? Yeah, so break at 215. Run this bad boy. Next. Oh, wrong one. Do it again. Okay, now we have an SSL object. And cannot establish SSL connection. So this is a different error, obviously. So let's try to reproduce it. Cannot establish. Why did it try to do it on all the threads? Oh no, it tried to do it several times. One, two, three, 4, 5, 6, 7, 8, 9, 10. Cannot establish SSL connection. How do we call SSL? I was fetching a page, blah, blah, blah. How do we make it? So what if we do https://localhost 8080 index.html? Okay. Advanced. Accept the risk. Hey, it works! Hey, look at this. It works. We got SSL working. That was actually not too complicated. Okay, so SSL works. So let's add that. Look at this. ARM core. And git ignore star.pem git status git add dot git commit feed TLS connections -m git push origin master. Okay, so this actually does work. We could think about offering both HTTPS and HTTP, but I really like this. Okay. Okay. So this is nice. And if we compile it with TLS0, okay, of course, pound if TLS and if we do this, we say localhost. I wonder why that slash page immediately returns. Maybe it tries that automatically. Okay. So this is nice. And some transfer encoding. Make the server multi-threaded. That's already parsing of the request target that we didn't do. Then logging. I want to look at PUT requests. PUT requests. Creates a new resource that replaces. So this may just put HTML. Then use the PUT method for user-initiated actions. Okay. So I think we want this PUT request here. So in our HTTP, we also introduce a PUT. Because we want to put content onto our server as it runs. Okay, so when we look at HTTP and parse HTTP request, we now, so these things are also somewhere. I wonder where they are. So they are here. Put method name put post put. Oh. Post put. Okay. Mem equal put. Mem.h and mem.cpp. Mem equal post. Let's do this. Return. So we have a haystack. The caller has to be as long as post, as long as put. Return haystack is equal to put method name 0 and star haystack +1. So put method name 1 and 2. Okay. So in our HTTP parse with HTTP request, we want to look at switch the method. So get and put are also the same. Put method name is the same. So if this is the case, else if mem equal put buffer result method is equal to put. So we should now be able to do some kind of put request. So when we say curl -x put localhost port 8080, okay, empty reply from the server. Let's empty reply from server. Return corrupted header. So that shouldn't be the case. So in our handle requests, parse HTTP request, and if it's not the case, look up status line bad request. It should write look up status line. Oh, that doesn't work anymore because character return line feed, character return line feed is missing. So we have to look up the status line. We have some response buffer here. So we could say response, so mem copy into the response, the corrupted header response, corrupted header status line, corrupted header status line, and then also copy into this character tone line feed and character tone line feed. So this is the default response length. This is the CRLF length. The CRLF length. And then this is the default response length. So this is plus 2 times CRLF length. Same thing here. Okay. Response. Now we had some response buffer. Response buffer. Request. Oh, we had some writer, buffered response writer. Go to close. So it would be more like writer. No. How did I call it? HTTP. Push stir. Push stir. Default response length. Push stir. CRLF length. So this is also something we could just hard code. So then this writer so we just write the buffer and now the writer dot buffer and the writer dot offset, the writer dot buffer and the writer offset, and this also applies to all of these things here. And this is also bad request. Is that the case? So right response. Push stir. Oh. Oh, so push stir does work just without the length. And maybe make this more performant. I mean, this is every time the same thing. We could just put it into the binary. Okay, default response length. We don't need that. Still an empty reply from the server. But okay, let's break it. Break 256. Yeah, 256. Run. What? Oh, okay, because we already implemented it. That is true. We now implemented it. But if we do something like a connects. Okay. So we just get a 400. Good. Okay. Okay, so get hash get. We also need a handle put request. So this is the handle put request. So does the same thing. Okay. For now, this is just the same thing. So switch. Just copy this whole thing over. Put handle put request. And we could also do something debug mode TLS. So HTTP server. Connection reset by peer. Oh, because we compile it with TLS. No TLS. Okay, so now it works. Okay, so we get a 400. That shouldn't be the case. What if we do post? Oh, because there's no content length. Okay, so -d hello world. Okay, so this works. Okay, this works as well. So put does work as well. But in put, we want some password. So we need some way. Okay, again. Is this camera following me? No. No, okay. Sometimes the camera is following me, and I don't really like that. So handle the put requests. Okay, so if we have some content length, we parse that out. And in this case, we also want to try to specify the request target. And we can do all of this here. And now I don't know if we want to try to hard code it. So we probably need some. Do we need an authentication struct? We could. Huh. How do we? So the idea is, let's go back to the drawing board. So the idea is, I want some kind of newsletter. Hello? I want some kind of newsletter page, and obviously a newsletter page has some blog art, or yeah, some kind of articles. And I want those articles to be in some folder. So we have maybe a /articles folder. And here are the different articles. I don't know, maybe it's an HTML file. I'm not so sure right now. And this is obviously on the server part. Server. And me as a client, I don't want to restart the server every time I add an article, so I don't want to SSH into the server. I want to make a request. Put article 4.html with the content, I don't know, blah, 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 blah. And the server goes ahead and makes a new file that is called article 4.html here. And also we have some index page that holds links to these. So when the index page gets updated, when we put a new article, we have to. So what I was thinking about was adding a template to this HTML file, where we say, I don't know, the template starts with two scrolly braces, and we say blog articles. And every time we put, we have to update the file cache. File cache. Oh. And update the first part of it. Is that? Yeah. I think this is how I want to do it. I mean, I can also, yeah. And also not everyone should be able to do this. Just, so this is quite dangerous actually, when I think about it. So we need some auth here. If everyone just can put articles on my site, that would be quite bad actually. Yeah. So we need a password hash, and we put that hash and try to we compare against the hash, and if it doesn't match, then we just do boom. It doesn't work. Yeah. So we need some way of hashing also, but maybe let's just try the first. Maybe let's try to first get some content and put it in some folder. So in this case, we maybe could pull this into another function. I don't know. Let's just leave it like this for now. So if we have the content length, if we have a content length, we want to, so this is something we probably don't want to do. And now we want to match to our routes. So we probably just hard code it. Hard code them. So maybe in HTTP we just say, I don't know where we do it. Maybe here const expr car article add article route, add article route, and this is just slash articles, add articles, add article. And yeah. So in this case, so the request target is a string. Maybe we just make it a string as well. Article string add article route string, and this is yeah, just that. So this is add article route, and the size of add article route -1. And if the request, so we have some string equal here, probably string equal, yep. So string equal request request target, and obviously our add article route string, and let's cast this. Okay. Else we probably want to return a not found. So this would mean not found. And also probably maybe you want something like newsletter sign up route newsletter sign up, and the same thing, add article dot star article route no add article route slash newsletter sign up route. Okay. Oh, that was stupid. Sign up route string. Okay. Maybe pound define string this a, and this says multi-line multi-line define C. Okay. So we would say const expr car. Oh, and it also needs a name, so base so name value probably. A name, the value, then this thing, name, size of value -1. No, this is also value. So whoop, whoop. Okay, so this would be, I don't know if we can actually do this, so would say define string article route and add article. I don't know if we have to add a semicolon here. Don't think so. Make redefinition. Oh, I think this actually works. So we could say define string newsletter sign up route oh no, that doesn't work. Name string, a string manipulation C macro. Okay, it can't do that. We don't really need C macro string manipulation. String guising? What? String guising. We want to convert a macro argument into a string constant. We can use the is used with lean, replace it with the literal text of the actual argument, convert it to a string constant. String guising? No. Okay. And we could also try to do this here. I don't know if this works. Okay, I don't know if this works. Main. So let's break main run. So let's try to print the add article route. So this seems to work. Maybe we just use this. Maybe we just use this. So this could be a defined string, a 0 lang. This could all be a defined string. Define string. So we could record a macro here. So dw no. So dw I define string parentheses f this xx comma xxx. Oh no. Undo f this next. Oh. It's probably because of the undo. So define string parentheses f this xx I xx f this. Okay, so it didn't work. But okay. I don't know if the extra semicolon is needed. And then we just delete all of this. We have the hashes. So this looks a lot cleaner. Obviously now we get a lot of compiler errors. So this is now the host header name. Let's just search for a string. So content length header name. Transfer encoding header name. content length header name. I think this is better. Same thing for put. Okay, so just string header name. String header. So I think we had it 0 lang. No, this was dumb. 0 lang string. Content length hash. Content length string. Content length string. Header name. Insert. What? Content length header name. Okay, so okay. Host string. Where's host string? Okay, so this is in HTTP. Okay. Header name. Header name. Header name. Oh. Oh yeah, so it was add article. Add article. Slash add article. Yeah, so that works. That's nice. So we need the same thing in the post as well. So it was, oh yeah, so this is here. Here. So for post, the same thing. So when we do post, we, oh. Yeah, so this is add article. This is newsletter sign up route. Nice. Newsletter sign up. Okay. Okay. We could extract this part of the yeah, I don't know. So this works. Um, 1 second. Handle put request. Okay. So in this case, we should have some data that should be authenticated. So I think we have to just, oh no, so I guess the request should have some header auth string auth length, and that is something we can hard code as well. Well, that might not be. No, this is not auth. So this is the auth string auth, and has auth. And this should be the auth hash, auth header, no, auth hash, auth header name hash, and the auth header name. Okay. In our http.h we define string auth header name as custom headers http. I think there's something here, custom headers. How should we name them? Okay, so authorization. Authorization. Yeah, okay, so maybe we just call it authorization. Auth header hash auth header auth header name. So this is the auth header hash. Okay. We can hard code the hash of the password into the binary, but if we want to change it, it would be, yeah, we'd have to recompile it. So probably we put it in some file. So we hash it on the server, I guess. So if not has auth, we init an empty response, return. Do we do it? Do we say that every put request should require auth, or just, yeah, I think every put request. So let's see. And how do we authenticate it? We could just compare some hashes. Do we just compare hashes? Or do we tell the client to sign something with the key? I think we just compare some hashes. To do, make this not so hard coded. Define string, put password hash, and what could be a can we do a SHA-256? Man, OpenSSL SHA-256. OpenSSL create SHA-256. Generate SHA-256 hash Linux. Okay, SHA-256 sum 1, 2, 3, 4. Man, SHA-256 sum. Okay. No, no. For files? No, I don't want a file. Digest. So echo, what was -n? What was -n again? echo, man. Output train line. Okay. So echo dash n 1 2 3 4 OpenSSL digest SHA-256 and man OpenSSL digest where digest hello parameters and my calculations. Where hello SHA-256 OpenSSL just SHA-256 out. No. To standard out. Iris. Generous A. Encrypt. What? Oh. Oh. What did we do? So echo dash n. That was stupid. 1 2 3 4. Pipe it into OpenSSL digest. SHA-256. So this is the hex representation, I suppose. Now we have to convert the hex representation to a string. Second. Sorry. Okay. We have to convert it to a string. Lua hex to string. I don't know. Hex to string. Core byte. Replace every car. No, this is hex decode. To number. Okay. Hex decode dot lua. So local hex decode. I don't know. Lua local function. This takes. Lua local function and okay, so this takes some hex It's like string.gsub. No, it's hex, and then double colon g sub %x, and substitute with function digit d or n, I don't know, and then return string.car. Oh my goodness. ToNumber N16 and then what? Oh, and okay. Okay. String.car ToNumber. Okay. Lua command line arguments. How do you do that again in Lua? With dot. Was it dot? Yeah. So args is equal to dot. Arg v use proc. I think it was like so local args is equal to this table, and then args 0 print so Lua hex decode hello nil. Okay, so this would be the hash. So cat no open so exactly this echo n 1 2 3 4 open SSL digest copy. No, how do we do this? So this is set dash e dot star space dot star equal sign space capture group dot star 1 and then pipe this into copy. Oh no, do something like this. So hex decode dot lua Okay. Hex decode and then hex decode args print 32. What? G sub do we need, I mean, I can make it in a single line. G sub this. It just prints %x. Hello? Let's try it this way. Oh, return. We could also just use the bytes. I think it's easier if we just use the bytes. So SHA-256 should always be how many bytes? 256 over 8, 32. So let's do this. Pipe it into word count -c 65. Should be 64. Okay. So 1, 2, 3, 4, 5. Yeah, it doesn't make sense to count it. So maybe just take this, say this is define, no, const expr car is equal to this. Then record a macro. No, record a macro. No. Record a macro, insert this, this, comma, escape. This was stupid, but okay. So now we have to replace this capture group dot star this. No, it's 2 digit. It's 2 digits, so it should be d slash 0x /1 and global. Ooh. Zero X. Oh, because it's not digit, it's just anything. Yeah. So you now know that my password is 1234. This is 1234. You know it now. And it is hard coded. Yay. But it won't stay that way. Smiley. I bet you if I Google this hash here, okay, I get this. Nice. Hash for 1234. So could have just Googled it. Okay. So when we have this thing here, and we want to check now if the string equals, yeah, this is now a problem because this obviously doesn't work. And this also has a size, like I mean, this has a size. Okay, so maybe we should make a new authentication.h and a new authentication.cpp and authentication.h pound if not define authentication header, then define the header, and if this probably has to include OpenSSL and OpenSSL digest, probably header sha.h. And we say something like authenticate and so authenticate authentication, include our authentication.h. And OpenSSL SHA-256. It wants a SHA-256 init. So it wants to do this here. MD. Okay. SHA-256. Oh my goodness, just scrolls down again. So SHA-1 init. SHA-256 init probably. Init. And it wants a SHA-256 context. Context. Just go to context. If this is, I don't know, what does it return? Return a pointer to the hash value. Oh. SHA-256. Okay, so that we don't know this. We don't need this. Okay. So just data unsigned car MD buff. Let's read this. Does it? All the functions described on this page. Okay. SHA-256. Let's open SSL. Computes the SHA-1 message digest of the n bytes at D and places it in MD, which must have space for SHA digest length 20 bytes. SHA-250. So SHA digest length. SHA-256 digest length. Is that something that exists? SHA-256 digest length. Is that something that exists? SHA-256 digest length. Let's assume that it exists. Okay, so this expects unsigned car. So this is okay. Authentication. So this is a U8. This gets the data. So This gets obviously the data pointer, the data length, and the mdbuff, which is just a mdbuff u8 star, and this returns. So return value, can this return value be okay. Okay, so this is the mdbuff. And if mem equal, so this mem equal SHA-256 digest, we could make an optimized SHA-256 digest compare digest length, and this is the mdbuff, and our, how do we call it, put password hash, put password hash. So return mem equal this. I think this returns a bool. Okay, so in main we authenticate, if authenticate, auth, if authenticate, auth, sorry. So if authenticate auth, then we do this. Otherwise, a bad request. Let's see. Zero x f0. Why? Why would that be narrowing? 172 is perfectly fine. Oh, so that's an HTTP. Authenticate. So we also need to include authentication. And also in our makefile, we have to include HTTP authentication. Do no. Okay. This obviously depends on authentication.h. this also has to link. Okay, so we might have it twice here. I think we only have to link it here, actually. Okay, so here we have to link it anyways, so LSSL. But here we only have to link it if so. We need the C flags here. So let's say linker flags plus equals LSSL. And then here the linker flags. I'll link SSL. Link SSL. Authentication.o, authentication.o. Data was not declared in the scope. What are you even telling me? What? Data was not declared in the scope? Oh, include types.h. Redefinition. Oh. String.h. Was it in string? No. It was in mem. That's very convenient. mdbuff. Mem equal uses car star. That doesn't really matter. Const unsigned car. Why do you want to? Why? Why do you want that to be constant? Const unsigned car. Okay, undefined reference to SHA-256. So this is L SHA. Still. Okay. SHA-256, undefined reference, okay. I mean, we linked against it. Do we have to link it here again? L SHA L. Link SSL. L SHA. Link SHA OpenSSL. How do we link this? Crypto. L crypto. Do we have to link it here in the first place? Make clean. No, we don't. And we don't have to link it here either. So link SSL. Okay. And if we use the CC clang, that works as well. So if we do this, we disable TLS, run the HTTP server, then curl-x put, make it verbose, localhost 8080 and /add article. It makes it 400, which is what we want. Curl add header. How do we make headers again? Man curl header. No. I think it is -h. -h. So curl-h and then authentication 1 2 3 4 1 2 3 4. Make it verbose -x put localhost 8080 add article. Oh no, it was authorization. What was the difference again? Authentication versus authorization? Okay. Yeah. So it was authorization. Still. Okay, it did cut off the content length. Oh no, we need some data. So data, hello world. Yay, it worked. If we do 1, 2, 3, 4, 5, it doesn't work. Okay, we have some basic authentication going on here. There's just a SHA 256. And we hard-coded it, which is not so nice. So first in our main, before we do anything, we probably have to set the we have to set this password hash. And we could make this a global variable. I don't know, or we compile it just into this. I mean, hard-coded things, not so nice, so I guess we do something like load env. And in the load env, we load env. We just open a file which is yeah, predetermined. So const expr env file is env. This can also be, so let's do like this. So if not define private key path, define private key path as key.pem, and if, and the same thing if not define assert path, define assert path as and if. Assert.pem. Private key path. Okay. So do we want to load this env? So if we have it compiled into this, it's probably not so nice. So it's probably not so nice if we have it compiled into the binary. But then we also have to do all these additional checks. Yeah, so auth hash if not defined, auth hash path, define auth hash path as auth .conf, I don't know, end if. So we try to, so someone that actually can alter this file can also alter this hash. We can bake the hash into the compilation. It's not so nice. Yeah, so maybe we just load this thing. So in our main, load auth hash, I don't know, load, or we call it load env, and we say open auth hash path with read read only i32 fd if fd is equal to -1, return -1, read, and then we want to read so this is equal to nothing, read, and then into the put password hash we want to read from the file descriptor. We want to read SHA-256 digest length bytes, and this also returns some, so i32n if n is not equal to SHA-256 digest length, then we return -1. Otherwise we just return 0. So this sets up our password hash. So this should work. Make HTTP server. Okay, read only. So open part of libc fcntl. SENTL. Oh, that was wrong. Make HTTP server put password hash. Put password hash. This is the SHA-256 digest length. Read oh my god. And also read. Oh no. Oh no. Also read gets overwritten. I think we have to call this sock read. So sock read. Sock write. Read. Sock. 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 This is not the sock read. Right. I think you only use it once. The sock right. Okay. Okay, read. Okay, here. This is casted to avoid star. Else read write uninitialized const okay, so HTTP no authentication, this is just equal to 0. So HTTP server curl-x, so curl-x, make it verbose, header authorization. No, so this shouldn't work. Load env. So if load env is equal to -1, return -1, fprintf standard error. Cannot read authentication config. Make HTTP server. Cannot read authentication config. So where was that echo thing here? Echo this, put it into our auth.conf. Auth.conf. Okay, so this is wrong. Nvim auth.conf. Diet space. Cannot read auth.conf. I thought I said it's called auth.conf. It is auth.conf. Auth hash path read. Auth hash path. Okay, so GDB HTTP server, break load env, run, next. No. Make HTTP server debug mode 1 TLS 0. So HTTP server break load and run auth hash path. Nice. So it can read it. N is -1. Main. I wonder what the erno is. Erno 14. Operation already in progress. What? Are you kidding me? Operation already in progress? So red val is equal to this. I16 red val. Return red val. Close FD. If close FD is equal to -1, red val, we could say red val is equal to this, or just return. Okay. So why are we unable to read the file? Open path name, auth.conf. We have the auth.conf. LSLA. Ooh. Ooh, that's bad. Because we need to write bytes. Write bytes, Linux. command line. That's one file to another. Byte sequence to file. E echo dash E. Okay, so the problem is that this is just the hash. We have to convert this to bytes. So we have to read all this shit here. Excuse me. We have to read all of the individual characters and make a byte out of this. Which we should probably do. So the digest length is obviously 64. Load env. So so let's say we have some car password hash stir, and this is 2 times the SHA-256 digest length. It's just the size of the password hash stir, and read it into the password hash stir. Okay. Not equal to the size of the password hash stir. Okay, and so now we have to say stir to U8 array. SHA-256 stir to U8 array. The result will be the put password hash, and we use the password hash stir to hex decode if hex decode is equal to -1, red val is equal to -1. We can't do this, so if equal to -1, red val is equal to -1, return red val. Okay. So now we have to hex decode something. So this is ith 16 hex decode, and we get some car star or U8 star, some car star and some U8. No, this is the result, U8 star, and the input car star. And We also need a size, which is the size of hex decode SHA-256. Authentication. Node. The caller has to ensure that the length of the provided buffers match the SHA-256 digest length. So what we do here is basically for int I is equal to 0, I is less than SHA-256 digest length times 2, and then say I plus equals 2. So let's make a table. So what is the ASCII code of A, B, C, D, E, F? How do we do that? Lua, car byte A. A byte string dot byte 97 48 B 98. So we should have, so we have basically two tables. That we can index. So as if, say, current pointer, digest, stir, and the digest buff is equal to the digest stir current pointer plus equals 2. Okay, so we say U8 digit is equal to star current pointer. Next digit is equal to, oh, we do 2 at a time. Yeah, so we can do this. Plus 1. Next digit, or digit 1, digit 2, and then current U8 star current digest pointer. Or we can just use the digest buff. Digest stir. Okay. So digest stir. Digest stir. And then we have both digits. We say hex value is equal to this times 16 plus star digest stir plus 1. So this is the hex value, and this is what we put into our star. No, this doesn't work. Okay, so if the digit 1 is greater than or equal to the 0 and less than or equal, and the digit 1 is less than or equal to let's say I16. You could just have a table. We could have a table. Let's go into our authentication and const expr hex u8 hex lookup table. Okay, so first it's just 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the A is 97, so we need, so 0 is 48. 97 minus 48, 49. So what is of 9? 57. And now we have the 8 is, so 40 zeros. 0, 0, 0. 40 zeros, and then 10, 11, 12, 13, 14, 15, 16. I guess. So one could theoretically put invalid characters into this and get just zeros. I don't really think that's an issue here. So one could actually go ahead and, so these in between, do we care about them? I don't know. So in authentication, we just use our hex lookup table. So we subtract the 0. and then we try to look up hex lookup, no, IDX1, so for IDXA, IDXB, and if IDXA is less than 0 or IDXA is greater than size of the hex lookup table, greater than or come on, greater than or equal, return -1, and the same thing with IDXB, IDXA, IDXB. And if this is all not the case, we just say star digest. Okay, so here we also need to say plus digest buff. And here we say star digest buff is equal to IDX hex look up table at index IDXA times 16 plus hex lookup table IDXB. Okay. Okay. So in our main load-env, we say authentication hex decode SHA-256. So hex decode SHA-256. Hex decode SHA-256. Okay, so let's debug this. Make HTTP server debug mode 1 TLS 0 hex decode SHA. Okay, so this is a U8. This is a U8. Hex decode. No, authentication. And here return 0. And maybe CC clang. Make clean HTTP server, and it's seg faulted. So break load env, run, next. So p password hash stir. Nice. P size of password hash stir. Okay. P hex lookup table. Okay. Okay, so here's the segfaults. So break hex decode SHA-256 run p digest buff digest stir IDXA B in authentication.h. This what? So what exactly is it that hex decode SHA-256? Password hash. P digest buff. So this is this. So that works. That works. Why does it segfault then? Hex lookup table at IDXA times 16 plus hex lookup table IDXB. This is 3, which is correct. And it doesn't work. Why can't we just override at this pointer? Sixth segmentation fault. Can't we override this? Oh no, so I suppose this, we can't do this. So go to our main.cpp. Can we just have a I mean, we can have a U8 put password hash. That is the SHA-256 digest length. That's something we can have here. Authenticate put password hash authentication okay, so note the caller has to ensure that the hash has the size of a SHA-256 digest. Mem equal, and then this is the hash. So in here we say put password hash load env. This already is a U8. Hex decode mem equal authenticate just that okay, I forgot to save it. So okay, so it failed. GDB HTTP server, no, break at load env run. Okay. So this is the put password hash digest buff. Okay, so this has 3 now in it. Add SHA of course that doesn't exist. Okay. Why is it all zeros? I thought I had incremented it. Okay. Why B? What? Why is it all zeros? Why is it all zeros? This should increment the digest buff. Why does it become all zeros? Okay, I don't know. Let's try to make clean. break at hex decode SHA-256. Okay, so print the digest buff, print the digester. Okay. So PIDXA, PIDXB, P star digest buff. Okay, so this is 3 now. Okay, yeah, so probably alright. Okay, so we have some iterations to go. This is stupid what I do here. Okay. So break 608. Main.cpp 608, continue. That was stupid. Break main.cpp 608, run. So print the put password hash. Okay, I don't know. I think this was the right hash. 1, 2, 3, 4. Yeah, let's see. So it's 03. Wrong. Okay, so it's wrong. Hex lookup table. And then add a minus 0. 0? $49. 49. 0. Okay, so there is an issue. So this is 10. What is it at 50? And at f minus 0 is 14. But it should be 16. Where's it 14? No, it should be 15. So there's one missing. This? Break. Zero XA. So there's a C missing. 16. Okay, so it's still off. Has to be one less. I don't know. Maybe like this. Break 608, run. That looks about right. Okay. And it's still... It's not capable of doing it. Where does it crash? Break main, run, next. Why does it not print? Break, load, env, run. Zero. Oh my goodness. How often did this happen now? Oh my goodness. Okay, now it somehow works. Let's check if it does work. Put localhost 8080 add article dash data hello world. Oh, it did work. Was rejected. Articles. Provide no data. Nice. So this is kind of good. Okay. Git status. Git oh no, ARM core. Git status. And then git ignore star.conf. Git add dot git commit feature added authentication to put requests. So we actually started with authentication now, but that might have not been the smartest thing to do in the first place. We could have obviously gone with trying to put some files on the server. But I think we will leave it like this for today. And continue tomorrow. Trying to put some files onto this thing and maybe starting with the templating. Yeah, so thank you for watching. Leave a like, subscribe if you want, and wish you a nice day. Bye.